especially in the recent, year or so, how things have developed around Spinnaker. It's great to have an audience of people that are interested in the community, interested in the technology, have heard about the benefits and everything that come with deploying Spinnaker. So first of all, shout out to our sponsor, Salesforce, for enabling us to do this, helping us out in providing this content and this platform that we can share this information with you and a little bit of training, get you a little bit of samples on that. So we're pretty thrilled about that. And also, the continuous delivery foundation who, kind of monitors platforms such as Spinnaker, who in the spirit of delivering software very fast and improving innovation and getting code out to production, we definitely love being under that umbrella with those types of technologies. So let's talk specifically about AWS deployments. So far, we've kind of covered some of the software development lifecycle aspects, some of the cultures and thought processes that go behind that. Andrew did a great job showing us how we can deploy to Kubernetes resources. So these could be Kubernetes clusters in your data center. These could be public cloud versions of your Kubernetes setup. So really leveraging Spinnaker as a platform to ensure that those containers and those services get deployed correctly. And but it does much more. And so I'm going to cover a little bit of that and discuss kind of some of the topics around Spinnaker. So Spinnaker is, off the shelf, out of the box, is a multi-cloud software delivery platform. And so this is something that Justin referenced a little bit in the first session that we had this morning. And the reason that this is important is that it really bakes in a lot of the best practices in deploying to these cloud targets into a unified platform. And so, we see here all the targets such as AWS, Azure, Google Cloud, Kubernetes, right? And what's really important about this slide is as developers and as businesses kind of identify these targets as things, as places where they'd like workloads to go, they are often having to figure out how to do plugins, how to do scripting, how to properly do rollbacks and rollouts across these different environments. So it puts a lot of pressure on the development team to have to kind of come up not only with developing code and some sort of testing practices, but also of having to figure out the right orchestration to talk to these different clouds. And so it's pretty nice to be able to have a platform like Spinnaker that you get all of these years of best practices and codes, you get stateful deployments, you have versioning, and so a lot of really great baked in tools in deploying a lot of these services. So today we're going to primarily focus on AWS, although the configuration across these cloud providers is pretty consistent. It's set up kind of in the same manner. So we'll discuss that and walk through those different things, but we'll primarily focus on AWS. And what we find is if we peel apart this actual deployment and we look specifically into the AWS cloud provider, it gives us a lot of functionality that allows developers to be very creative in how they want to develop services and deploy services. So by configuring the AWS provider inside of Spinnaker, we now have this, these best practices and these golden paths to deploy to things like EC2 for some of our legacy workloads that might be VM based. We can still provide Spinnaker functionality and deployment methodologies and things to EC2 instances. It also has full support for container orchestration platforms that are not Kubernetes. So I've met a lot of companies that definitely are moving into a microservices direction. They understand that the container is a unit that can be developed and run in any cloud. And so it's extremely nice for them or those organizations that might not have Kubernetes shops to be able to say, hey, we'd like to take these workloads and we'd like to deploy them to ECS, or we'd like to deploy them to Fargate. And this is actually quite popular. I mean, Amazon actually makes quite a bit of revenue off of a lot of workloads that are running in these other container platforms besides Kubernetes. And from the same Spinnaker provider, you do get EKS support. And so everything that Andrew just showed you there around, grabbing artifacts and deploying containers and maintaining those workflows and those rollbacks and those advanced deployment strategies, all of that is baked into that for EKS, just like it is for any Kubernetes cluster. And then kind of referencing back to, what Justin spoke about a little bit this morning, which was serverless functions, right? Lambda functions. So I don't want to maintain the container. I would just like some code to do something. And so having that as well as a a target for these workloads is extremely powerful for organizations. And so this would be consistent and pretty much true across any of the cloud providers that Spinnaker has today. Now, one of the newest things that came out that was announced was actually a new AWS platform, which they're kind of building out from their knowledge of everything with ECS and Fargate and EKS and how to leverage AWS cloud in the best manner. Came out with a new service called BottleRocket. And so what's great about that as well is Spinnaker has been validated against BottleRocket as well. And so if that is a deployment methodology that fits your team the best and allows you to provide those workloads and deploy those workloads, what's nice about adopting Spinnaker and enabling the AWS provider is you already have a way to deploy to these in a very similar manner that you would in any of the other targets that are inside the AWS cloud. So it's actually pretty easy, and we've baked it kind of down into 3 steps. And so to get Spinnaker provisioning and talking to AWS through the provider is very simple. So the first step that you have to do is prepare your cloud environment. So this would be true pretty much against any cloud. So you have to have some sort of roles and permissions, some sort of levels of access. You may have multiple accounts or different regions or different clouds that Spinnaker may talk to. But at the end of the day, what you need to do is provide the appropriate roles and permissions for Spinnaker to do its deployment into your cloud targets. So that's step 1, is preparing your web environment, or I'm sorry, your cloud environment. With these different roles and permissions so that Spinnaker can do its job. The second part is to actually port these configurations. So take everything, take these roles, take these accounts, and actually get these into Spinnaker's AWS provider so that you can enable and leverage all of these different cloud targets that you might have. So after setting this up, you now have inside of your organization a way that you can deploy all of your applications out to any of these targets. So you're no longer strained by, okay, hey, today we want to do Lambda functions now for this particular service that we're bringing online. So we're going to have to understand, how do we properly deploy out a Lambda service? How do we roll back a Lambda service? How do we orchestrate things around Lambda? And what's great is taking out all that guesswork, taking out all that custom code and scripting, and just relying on Spinnaker to do it, which it's already baked to do, is extremely powerful. And it really enables development teams and businesses to innovate at a very rapid rate. The third part is easy. After that, you build a pipeline, just like we saw Andrew do for Kubernetes a little bit earlier. We now have everything that we need inside of Spinnaker to build out our pipelines. And so a pipeline, as you guys have seen, is just a way to orchestrate your workflow with a bunch of very powerful stages in line that will dictate how your application actually gets to the end target. Now, as I mentioned, I don't have as much time as I'd like in this session. I usually like to have labs around each 3 of these specific areas. So I do like to walk through people of preparing your AWS environment, getting those configurations into Spinnaker, and then actually building pipelines. So today what we're going to do is we're just going to quickly kind of glance over 1 and 2. And we're actually going to build some pipelines on number 3 so that you can actually see how the provider works for non-Kubernetes workloads. But if you did want to get some additional work on this, I highly recommend that you kind of walk through what we've laid out to actually do these steps on your own. So we have a self-guided path tour that you can take back to your organization, you can take into your AWS account or your cloud account and be able to run through these steps and be able to validate and just get additional work in building pipelines and using some of the things. So to start off, what we normally say, or a quick way to get it up, is to look into Project Miniker. So Miniker is a self-contained Spinnaker installation inside of a virtual machine. So it's a very quick way to set up Spinnaker to be able to configure the providers you need and then start building pipelines and deploying code through Spinnaker. So a very nice way to validate it. Another cool way that you can do it is through Operator, which is installing Spinnaker from a Kubernetes object model, which is extremely nice and easy and very powerful. The second step is to kind of take those 3 steps that I highlighted a little bit earlier and walk through those steps in a configuration. So we've laid that out in our documentation to make it very simple to walk through those configurations. And we even have video tutorials that we could that you can look at inside of the documentation that will walk you through how to actually set those steps up. So it's completely self-contained. You can go at your own pace. You can do step 1 at the beginning, step 2 the next day, step 3, and then start deploying with Spinnaker. And all you'll need to actually accomplish this is an AWS account number, a text editor, some copy and paste skills to be able to move JSON back and forth and change configs, and then a workstation as well that can talk to Kubernetes if you'd like to deploy to EKS. And really that's it. That's all you'll need. So no Terraform, no scripting languages. You don't need to you can come at a very entry level into Spinnaker and be able to stand up Spinnaker and get it deploying for you. So as I mentioned, we're just going to discuss, I'm going to kind of overview and just show you what step 1 and 2 look like inside of the provider and how to set that up. And then we'll specifically do our lab around step 3, which is going to be building out some pipelines. I'll walk very slowly through that. I recommend that you stay in our environment that we have set up for you, and you can actually go ahead and deploy that, those pipelines as needed in line with me. Right, so we'll take a look at that at lab time, right? So I posted into the chat where you can actually get the line item of what you would like to see for the deployment or the actual configuration for this lab, in case you get lost. But I'll probably take my time and walk through it pretty slowly, show you the different options, talk a little bit about Spinnaker. And yeah, if you have any questions along the way, definitely put those into the chat. I'll try to address those. All right, so let's pivot real quick. I'm gonna go ahead and go into the Spinnaker configuration that we have here. But actually, sorry, before I do that, let me cover exactly what I mentioned here. So here in the configuration docs, right, we have exactly what you need, a step-by-step guide of copying and pasting the different roles into AWS. And so you can see the associations between the managing role that you'll actually have applied to your EKS nodes or to your Spinnaker nodes, and then your manage that you'll have across accounts or across regions that you'll use as a deployment account that you can assume and deploy into your given targets for your application. So we have it step by step. You kind of walk through each of these. Just basically, we've templated out your AWS account number that you would input here, and then some validation steps that we have, and then a video here that'll walk you through all of these steps in kind of a self-paced way that you can get these configured for you. And so step 2, again, is just getting those into Spinnaker via Halyard. So Halyard is a nice, is the configuration interface that you'll have to Spinnaker that will allow you to basically get those configurations set into Spinnaker, and then you'll be at a state where you'll be able to perform the labs like you did today. So if this lab is something that you like and you'd like to take it back into your organization and set it up with your own images, your own artifacts, and be able to validate and show perhaps other groups or other teams what that looks like, I highly recommend running through this and getting that set up. And so what that looks like inside of AWS is once you're in the IAM and you come under roles, you'll have essentially 2 roles by the end of the QuickStart guide. And so those will look something like this. So you'll have a Spinnaker managed role here, which will have the trust policies associating it with the managing role. And so really with the 2 roles that we have set inside of the QuickStart guide, you'll be able to deploy to ECS, EC2, you'll be able to deploy to EKS, Lambda, all of the different objects that you'd like to deploy to. So I don't want to spend too much time on that. I'm going to kind of jump right into the lab itself. And so for those that want to follow along, please do. This is the interface here I'm going to kind of use to validate that we are deploying into AWS. And then here inside of our dev gardening instance, you can configure your application as needed. So just like you did in Andrew's session, go ahead and go under applications. We're going to kind of kick off the lab here. If you get lost again, the documentation is inside of the chat screen. So I'm going to create an application here. And I think just for maintaining, you could put your full name. You can put anything you like as an identifier here in the first part. And then go ahead and input your email. And then you could even add a some sort of description there that kind of gives it a little bit of context on who you are. And then under the cloud providers here, this is the step where you'll associate the application with the given cloud provider, right? And so here we'll want to select AWS as our provider for this application. And then we can click create in the bottom right-hand corner to create this application inside Spinnaker. All right, excellent. So now we have our app. You can see our application name here in the top left-hand corner. As we see right now, we don't have any sort of infrastructure. We haven't provisioned any load balancers from Spinnaker, a firewall inside of Spinnaker, and the context of AWS is a security group. And so what we'll do is we'll navigate here to pipelines, and we'll build our first pipeline for our application. So let me slow down here. I'm just going to take a second and let everybody kind of catch up. For those who are following along and want to build an application, go ahead and configure those inside of the Spinnaker gardening environment that we have set up for you guys. And then I can go ahead and start kind of walking through this pipeline and how we're going to deploy this. All right, so let's configure our first pipeline here. This, in my sense, I'm going to go ahead and I'm going to put my name. I'm going to put EC2 as my identifier. And then I'm going to call this one Chad EC2 deploy. Click create here in the top right. And so this will be a deployment a little bit different. So Spinnaker is not only a Kubernetes deployment engine, it also deploys instance-based workloads, which is good for applications that don't factor very well into containers that you might be running inside of a deployment today. But it may be a component of a larger application that may be VM-based with some microservices providing functionality for some legacy code or something like that. And so what we'll do here is we'll add a stage. And inside of this new stage, what we're going to do here is we'll select a bake. So Spinnaker has the ability in a service called Roscoe inside of its platform that allows you to bake an image. So you can take base AMIs, you can take something that is produced by your CI system and apply some configurations to it and actually bake an AMI and be able to have that AMI available globally in any region by running through this particular step. So we're gonna select the type is gonna be a bake stage for this one. The stage names here are where you can put kind of internal identifiers. So if you're moving some functionality from what you have today, but the nomenclature and the naming conventions that you guys use, you can definitely insert that here to kind of personalize it and make things referenceable inside of Spinnaker for other groups and other teams that may use the same naming convention. So in this case, I'll just do like a bake new AMI for deploy. And so here inside of the stage, I'm going to start to build out some configuration. So as far as the top piece here, configuring the actual stage inside of Spinnaker, that piece is set. And so now what we'll do is we'll focus in on this bake configuration that we have here. Now, this particular cloud provider that we've set up is only configured to deploy to US East 1, but what you would normally see in a production Spinnaker is many regions listed here, and you can select all of those. And that's actually really cool because I've worked with a lot of companies that want to produce the same package and then push those AMIs globally out to their given region, right, with different AMIs. And so that's something that's easily done and works out of the box with Spinnaker. So that's a nice to have. Inside of the package here, if you're following along, just go ahead and put Nginx. We're just going to do a simple Nginx that we're going to bake inside. And as our baseline image that we're going to use for this bake, what we're going to do is you see we have options for Windows workloads. We have some other Linux flavors, but we're going to select the Bionic 1804 version. And so go ahead and select that and then make sure your package name says Nginx. And then what I'd like to show you here is some of the advanced features that we have inside of Bake. So this might relate to some of the stuff that you guys are doing today, where you have a particular template file. So here inside the template file, what we want to do is actually put AWS ebs.json. So if you're following along again inside of the lab, go ahead and put aws-ebs.json into the template field name. But what we actually see is some cool stuff here, right? I could actually use a base AMI, right? If I have an AMI that my organization uses as a base that may already be inside of my AWS region, then I can actually call that out here. And then it will actually override and ignore this base OS that we have going on here. Let me take a quick step here. I just want to check in on the chat. Okay, cool. Looks like Justin's got it. Thank you, Justin, for taking care of all those questions out there. Cool. So for now, for this particular stage that we have, we're going to bake this AMI. It's going to leverage Nginx as a package. We're going to send this to US East 1. And for the configuration of this stage, I think we're pretty much set. So go ahead and click Save in the bottom right corner, and this will save this stage as we have it here. And then now we're going to actually click on this stage and add an additional stage. And so here we've already baked, we have a particular image, right? I could actually type in deploy, and here we'll find a stage that actually deploys the previous baked version or a found image. So you could actually, instead of baking inside of Spinnaker here, you could have a stage that actually finds an image tag. So it'll actually look into your AWS account and look for AMIs that'll then pull into Spinnaker and use as part of this deploy process. So you get either of those here. And again, make these kind of unique to your environment where you're going to deploy. So in this case, I'm going to say, hey, this deploys to prod, production, just to kind of be thorough. And we're pretty much done now with configuring this stage inside of the Spinnaker pipeline. And so what we're going to do here is go into the actual deployment configuration. So click on Add Server Group. Right. And so we get this nice UI that pops up here. And normally what we would have is a select number of accounts here in this dropdown. We have an account AWS that we've set up in this environment. As I mentioned, we're only deploying to US East 1 in this case. And we've only tagged or identified a subnet inside of this VPC. So we can actually tag multiple subnets, and all of those will actually be auto-discovered through the cloud provider and brought into Spinnaker, so you have access here to deploy where you'd like. A stack name is a nice way that you can add some additional context on what this, what the fuller stack is of this application, this pipeline. So you can add a little bit of context here if you're working along in the lab as well. So add that under the stack. And then we see here traffic, right? So we're going to send traffic to this new instance, right? So if this was in front of a load balancer and we had some sort of strategies behind it, we could, as part of this deployment process, roll the load balancer to the new version of code and be able to test and validate that the new code is working. If for whatever reason our post-deployment verification inside of Spinnaker says the KPIs are off, or we're starting to get exceptions or errors in our external monitoring systems, we can actually automate a call back into Spinnaker and roll this back to the previous version of code. So it's really a big topic that we talk about a lot, is rollback and how much time it takes to get back to a last known good state. And so it's really kind of a key and an important thing about Spinnaker is to know that you can get back to a known good state very quickly, right? Most of the time automated, but definitely you have the ability to come back in here, click a button, and roll back a deployment. So I just wanted to point that out. So let's go ahead and scroll down. Now what we're going to do is apply our firewall. So a firewall inside of Spinnaker as it pertains to AWS is a security group. So I have one here that opens up 80 and 443 for me. So I'll apply that to my deployment. And what we also see inside this configuration is that the support for any of the instance types inside of AWS, right? So you can kind of set these to your application. You can template these in the JSON representation of this pipeline and be able to deploy the proper image with the proper workload. And so I'm just going to go ahead and select a micro utility and select Nano, just so we can keep it lean and mean. And then what we see here under capacity is our ability inside of Spinnaker to say, hey, you know, I want a number of instances. You know, in this case, we're going to do one, but I may want 100 of these instances running. And what this is going to do behind the scenes is create an auto scale group that has 100 of this particular image running inside of it. So we'll keep with one for now, but I did want to point out that we can address capacity there. Again, the AWS cloud provider is fully aware of region and availability zone. So you can do things, you know, as far as have availability zones for load balancers and such. And then scroll down here to the last step, again, we'll just kind of look at some of these configs. You may want to see here, you know, the health check type. Do I want to know from the cloud, or do I want to know from the load balancer that's provisioned in front of the cloud? So you may have a strategy on how you want to dictate health inside of the cloud. Now, what is required is a key name. So just like when we provision inside the AWS console and it says, hey, which SSH key would you like me to associate with this instance so that you can have access to it? We do the same here inside of Spinnaker. So we'll go ahead and apply that key name here. And then just before we jump out, you can kind of see, you know, all of these will leave default, but you can actually, you know, see what kind of depth and what kind of knobs you have in deploying these given EC2 workloads into AWS. So as far as everything that we need here, we're all set. We have the account, we have the region, we have the VPC subnet. I add a little stack information just to kind of personalize it. I would get into load balancers, but again, I think we would need an extended window or maybe a couple of 1-hour sessions just to get this thing from beginning to end on how we would like to deploy it. But this actually is pretty nice to walk you through on how to build these pipelines. So go ahead and click add. And then what we'll do is we'll save this in the bottom right-hand corner. And one thing I believe I forgot to do, so I'm going to take a step back, and inside of my application, I wanted to change, let me refresh this here. Sometimes the caching gets a little set. But what I want to do here is actually set the instance. I don't believe I did this when I created. So I'm going to go inside of the config here for the app. I missed a checkbox on the way in. Since we don't have a load balancer, I'm actually going to check this box here, and I'm going to consider what AWS tells me about the instance. So when AWS says, hey, the instance is up and happy, that'll be relayed into my Spinnaker configuration, and then I'll know. So I'm going to update that real quick before I run the pipeline. So sorry about that. We'll step back. But so now we have our pipeline. We have it fully configured, and if you're doing this along with me as well, we can go ahead and run an execution. So I'm going to go ahead and run this here. We'll take a look at the execution details, and we'll start to see some cool information here, right? So number one, we can see what our AMI is going to be called. We have our base OS. We have some templating information, which packages, where it's actually being deployed. From a bake AMI perspective, I can actually look into the logs here and, you know, get a very detailed, verbose look at what my bake looks like. So that's pretty cool. And another thing that we can see are the individual tasks. So we've already run through them, but it's always nice to see inside of a stage, since they are stateful, to see, hey, what is Spinnaker working on right now for this given task? If I go to the second stage of this setup here, what we find is that number one, we again have our information. We have our task list here. So we're waiting for the instance to be up inside of the cloud, and we're forcing some refreshes here. And what we've actually seen, which is pretty cool, is I now have my application name, I have my stack, and I have a versioning, which we know Spinnaker does, is version every deployment. And this is how you get rollbacks very quickly, or automated rollbacks when things don't go well, is because based on the state engine and the versioning inside of Spinnaker, we know it's deployed, we know it's been deployed. And also, this is really important across clouds, right? So if I have my Spinnaker hooked into AWS and GCP and Azure and some different Kubernetes clusters, I can come in here and I can look at it from an application perspective and see how Spinnaker evaluates the deployment, which version is out there in which cluster or which namespace, or, you know, which AMI is in which region. So it's pretty nice to see all of these here. And so we have it deployed, which is great. And so now what I'm going to do is navigate to my infrastructure tab. And what I see here is I can actually select my deployment. And inside of my deployment, what we see is all kinds of cool information about the actual deployment, right? So I can resize the server group, I can do auto scaling. As it stands right now, we're still waiting for the actual instance here. So I can click on the instance itself and I can say, oh, you know, really cool. I can tell what my server group name is inside of AWS. I can see all of my IP information and my DNS information. So Spinnaker has, you know, already set up Route 53 for me. It's already done auto IP allocation through public IP addresses. So a lot of these things that you would have to take into consideration as you're deploying your applications are all kind of taken care of for you inside of Spinnaker. So we'll let that instance come up, but what we'll do is actually kind of jump into the AWS console here. And if I come into my auto scaling groups, what I can actually see is, let me try the EC2 instances. Let me check, just make sure that this is valid. Let me refresh on this real quick. Might be in the, oh, I see. I am actually in the wrong, apologies, I'm actually in the wrong console, so under the wrong account. But what you would see inside your AWS console is essentially your auto scaling group that would be measured there. I can actually come in here, I can copy some of my public DNS information and be able to put that in here, and there you go. So we kind of walked through everything that we needed to from kind of an EC2 instance base. We leveraged some of the AWS provider information, which is cool. And what I could actually do now, if I wanted to make some changes to this, is I could come into here and actually change my deployment. So I can ask for another IP address and save that change. And then I may also too want to, before I deploy to production, add in here a manual judgment for somebody to look at a ServiceNow ticket, look at some sort of update, some sort of Jira information, something that kind of gives me some indicators on whether or not it's a good time to roll forward and move to production. So I can then come back in here and I will break the depends on bake new AMI for the deploy. And I'm instead going to say this is dependent on my manual judgment, right? So I've added an additional stage here in the workflow where I go from configuration, I bake my AMI, and then I actually add a manual judgment state here where I can stop and ask for approvals from different groups or an additional validation before we roll code into production. So let me save the changes there. And I'll go ahead and rerun my pipeline. And again, we'll just look at the execution details. Now, it was extremely fast this time. Spinnaker will actually cache the baked AMIs that it has from previous bakes. And so this is nice. You can't force it to rebake every single time, but it's nice to be able to save timing on that process if you need to leverage that AMI to deploy elsewhere. And here we've actually, in our new stage that we've put in place with the manual judgment, what we've actually done is put a halt here to say, hey, somebody take a further look at this. And what's also a normal hook that we kind of put into these manual judgments is some sort of update to a chat, such as Slack or Google Chat, or we also may incorporate some webhooks that we may send things to external systems to look for validation there. And then based on validation inside of those systems, it actually calling back into the manual judgment and giving the approval to move forward. Another kind of nice thing is you can change the account here at this level and be able to have that account push to the actual deployment. So you can actually do a distinction between who actually gets to create pipelines, who gets to do certain functions inside of pipelines, and then ultimately have a new account that will allow you to have the authorization to deploy to a given prod state. So here we see that we've upped our versioning. So we have a new version of the deployment, which allows us to do some really cool things as far as rollback, which we can take a look at here in a second. So if I take a look at the task, again, we're just waiting for that instance to provision inside of AWS. And so if I come back into my clusters for this, we can see I have my deployment, which is currently running, and here's my instance in an up state. And then here we haven't gotten health yet because the cloud hasn't indicated back to Spinnaker that it's ready for traffic or ready to go. So we could take that. But one of the cool things is you can see now, normally we automate this rollback function, but I could very easily, if this deployment were to have service level impact or, something that was disrupting the user base, we could come back in here and quickly roll this back. So pretty nice functionality. Another thing I'll point out here as well is very complex applications that are across clouds or across Kubernetes. What you'll have here is a set of different accounts and regions. And what's really nice about this is as a developer, I can come in and look at my given application, in this case, Chatripa. And inside of this application, I may have many pipelines representing EC2 instances or virtual machines. And then I may have many pipelines that represent microservices. In these microservices, some of them could live inside of the same cloud as the virtual machines. Some people I've seen will put web UIs into a different cloud with extended network. So it's a really nice place that the developer can come in. He can look at the state of his application, all of the pipelines that they have available to them, and really get an application-centric view, which is extremely nice to have instead of having to go through many cloud consoles and accounts and try to figure out the state of where things are at, especially when you're talking about rolling back code and trying to get back to a last known good state. So Spinnaker provides that kind of application-centric view into that. So I will kind of take a look at questions just to make sure that everything is getting answered there. Okay, yeah. So let me actually show you that. Some people did mention, we've been doing a lot of UI work here. So if I actually go into the pipelines represented in the application and in the pipeline itself, I can edit JSON. So what we've been building and everything that you see rendered inside of the UI here, behind the scenes to Spinnaker is just a bunch of JSON. And so what's great about this is you can share best practices. So you can take this code and give it to other groups that may be deploying EC2 instances in a similar manner, but their CI processes are generating different images and different artifacts. It allows for a golden path. It allows you to get out of the kind of one-off scripting and maintaining all these scripts and plugins. And through Spinnaker, you can kind of provide these best practices. And what goes into building all the guardrails into this, right, is operations and working with them and their clouds, how to understand the deployment target so they can bake in what is best from a deployment to the cloud strategy. You may have security teams that want to ensure that you have proper accounts at proper levels. You may also want to have the proper approvals to get to prod, things like that. So you can definitely bake in some of the guardrails from security as well. And then once you have a full pipeline, like you see right here inside of JSON, you can manage this completely as code. So this isn't something where you're reinventing the wheel for every single team, and every single team is doing something different. And, and then people change teams and leave and you don't know what's happening. You're providing a platform that has all of that ironed out for you and really just streamlining all of these cloud targets. So it makes it extremely easy to kind of be able to manage it that way. Just checking into chat to see if there's anything else. Thank you, Justin and Ed, for jumping in and getting everybody's questions answered. So I kind of blazed through that a little bit quicker than I expected. What I could show you is that in our deployment infrastructure here, I could actually execute a rollback. And so here is where you'll have all of your revision history of all of your deployments. Again, this can be automated. Andrew, who just spoke in the last session, did some really cool things with PagerDuty, where PagerDuty, is doing alerting and monitoring on a post deployment and having that kind of jump back in, notifying the SRE, but then also at the same time getting them into a last known good state. So you automate that process, you notify people through these kind of rollback situations, but I can easily come in the UI here and say, hey, you know what? I want to go back to version 0. Let me go ahead and submit that. And behind the scenes, the AWS provider between Spinnaker and the AWS APIs are making that rollback happen. So pretty nice feature to have there. All right. So just to kind of get back in reiterate. So this was, hopefully you did this task with me, but if you did not, you can always roll through this step here. So, just like just like any technology, you become proficient through kind of doing things over and over, becoming proficient at it. So if you thought this was useful, if you thought Andrew's pipeline building, his lab in lab 1, this lab in lab 2 were useful, you can definitely quickly stand up Spinnaker and start to deploy to at least AWS, although the concepts are pretty high. So I highly recommend that you kind of set this up yourself in your own lab and just kind of go through the process of setting up the cloud provider. We're here to support you in case you run into any hiccups and, help you along inside of your Spinnaker journey. With that, I think what I'll do is just follow up and see if there's any other questions in the chat, maybe that Justin and Ed didn't get to. Excellent. Yeah, no, thank you guys. Really appreciate you hanging out. And it looks like about 8 minutes early. So what I'm going to do is kind of propose a larger break. I know we're back at the top of the hour with Fernando, who's going to go over some Spinnaker concepts. Yeah, if there's not any other questions or anything, I guess, you know what, let me take a look and see if anybody has any questions about their pipeline, or if you weren't successful in baking an AMI or getting to your external IP, we can kind of work through those in the next 8 minutes. Thank you, Edgar. Appreciate it, man. Any kind of open the floor? Any questions from anybody who did the exercise and maybe ran into something?
So I didn't do the exercise. I just have some high-level questions about the AWS provider.
Yeah. Yep.
So as far as Spinnaker elements, what is the AWS provider? Is that, I missed kind of the first 10 minutes. I was a little bit late, but is it a plugin, or is it, I guess, the concept of a provider? How does that work exactly?
Yeah, no, that's great. Yeah, so what happened inside of the Spinnaker platform, the concept of a provider is a native integration with their APIs inside of the cloud. Okay. And so, but it's a little bit more than that, right? So the providers are actually written by the companies that are the target. So Netflix and Amazon have built the provider for AWS. Google, contributing to the community, has built the Kubernetes and the GCP interfaces, and Microsoft recently joined in the last year and built the Azure provider. So it's their best practices, their sequences inside of how to communicate with their APIs, the order of operations that have to happen to successfully deploy a workload. So that's essentially what a provider is. It's I wouldn't use plugin, since it's the integration's a little bit deeper, but at the end of the day, it's a way for Spinnaker to deploy, again, versioning, doing stateful deployments, able to roll back, everything like that.
Okay. And with those providers, like how, I guess in your experience, how up to date are they typically? I know with tools like Terraform, for example, it can take a little bit of lag, right? And it's kind of a similar idea, right? Like updating any API information. Do you find that it moves fairly quickly, or I guess it just depends, right?
Yeah, so it varies across clouds. And to kind of give you an example, I think you probably missed this part too. So like Bottle Rocket is a new container platform for AWS. So they, before releasing it, have reached out and made sure that Spinnaker could support the proper calls and the proper sequences and ordering and in deploying that. So it really depends. It varies across clouds. There may be some lag on some functionalities, but for the most part, what we see is that it's done, ahead of time at this point.
Okay, no, great. That sounds perfect. I really just curious from my end. I mean, I don't have too much experience with how the AWS and Spinnaker integration works, so that information was helpful. Thank you.
Yeah. Thanks, Dan. Great question. Any other kind of questions? We got 5 extra minutes here. Of course, we're here to help you out if you're doing the lab and you're not getting to your endpoint, or bake's not happening right. We can definitely answer those. But or if you just have kind of high level questions as well, we can. Is it, is it possible to pin a version? Yeah. So much like we saw with the templating through spell, passing either the latest tag or some sort of versioning information into Spinnaker and put that into the bake stage. So another thing that's great is artifacts and state are kept across stages inside of Spinnaker. So if you build out a pipeline and, you collect some information as part of the trigger, that information then is inside of that pipeline to be used later. And there's actually bidirectional flows too, where Spinnaker can take some metadata about the CI process or about the commit, pass that to a stage, and then that stage can actually send that information to another process, get information back about that. So yeah, you can definitely pin it to a bit. Really good question. All right. If there's not any more, oh, here we go. For exporting all of its configs and pipelines. Yeah, great question. Yeah, so there is a disaster recovery model in Spinnaker. It is an active passive model, but with a GitOps flow, you can actually build Spinnaker in such a way that you could deploy it on the fly to pretty much anywhere. So when we talk about kind of GitOps flow, we're talking about the configuration. We're talking about the YAMLs that build out Spinnaker, the platform itself. So it fully yields to a really nice GitOps model. And so it makes things like disaster recovery and reprovisioning and, sharing state. And, there's some database replication that has to happen along the way just to make sure that some of that stuff, but a majority of the information, yeah, is definitely available for disaster recovery. Great question. Thank you. All right, excellent. So I'll kind of propose that then we'll extend the break a couple extra minutes. So at the top of the hour, check back in. We're going to talk about some Spinnaker concepts. Again, thanks for the time. Hopefully, this lab was something that was useful and maybe something that you'll want to do again. And, if you run into anything or need any help, definitely just reach out to us and let us know. So thanks a lot. Bye, guys.